This is 7.2a. Simplify. Your answer should contain only positive exponents with no fractional exponents in the denominator. Sounds exciting. Alright, well shoot, here we have fractional exponents. Alright, so we can simplify this. This is all multiplication, folks. 2 times b to the 3/4 times 2 times b to the 5/4. So I'm going to take the 2 times 2 and pull that out in front, and then I have b to the 3/4 times b to the 5/4. You don't actually have to rearrange this, folks, but you should do this mentally if you're not going to write it out. And this is definitely something you can do in your mind just to see the pattern. 2 times 2 is 4. All right. So now here, oh my goodness, what do I do with this? Well, I'm multiplying together the same bases, raised to some power. That looks like this. When that happens, I add the exponents together. This exponent's m, this exponent's n, so I add m and n. Well, if it's a fraction, I take the fraction and I add it to this fraction. So it's going to be b to whatever 3/4 plus 5/4 is. Good thing when you add fractions, we have a common denominator because you have to have a common denominator in order to add fractions. So you get 8/2, which is the same. That's a bad looking 8. You get 8/2, which is the same as 4. Alrighty, same idea over here. If you want to throw a 1 in front of the n mentally, because like the 3 freaks you out, you can do that. But basically we're going to have 3 as a coefficient. So I have 3 times 1 times n to the 1/3 times n to the 3/2. 3 times 1 is 3. And then n is going to be raised to the power of, well, when I multiply the same base together, I add the exponent. So I have 1/3 plus 3/2. Now, in order to add fractions there, you have to have a common denominator. So think, what number does 2 and 3 go into, or what's the least common multiple, the smallest common number that 2 and 3 multiply into, and that is 6. Now, in order to get that, I had to double the bottom here, so I have to double the top. In order to get this fraction to have a denominator of 6, I had to multiply this 2 by 3. So if I multiply the bottom by 3, I have to multiply the top by 3, which gives me 9. And again, I'm adding these fractions together, so that gives me 11/6. That is my new power on the n. Boom, shakalaka. Next property, when you take a power to a power, you multiply those powers together. Now this is the same as 3/1. So if you want to think of it as a to the 7/4 times 3/1, you can, or you can just realize, meh, it's just 21/4. So a, and the power is 21/4. Beautiful. Same here. Now it's p to the 1/2, and you multiply that power with the power with 5/3. So now it's 5/6. That's the power on the p. I don't want to see your answer like this. I don't want to see this. I mean, I want to see this stuff. If you want to show it, that's good. I need to see your answer written nice and prettily like that. I'm not sure prettily is a word, but we're calling it a word now. When we divide numbers, folks, 4 divided by 4 is 1. So I get a 1. Now when, where'd that go? Can I copy and paste it? Copy. Zoop. And I referred to that property, but I didn't actually show it here. What we were doing on the last one was right there. If I have a power raised to a power, I multiply the powers together. That's what we did with the 3/2 and the 2 there. That's what you do on these. Now on number 5 and 6, we are dividing bases together. So when we do that, when we divide the same base, we subtract exponents. So I'm going to have an x. Look at that 1 I don't even need. And then I subtract the top exponent minus the bottom power. The top power minus the bottom power. So it's 7/4 minus 5/4. 7/4 minus the bottom one. That's 5/4. Good. In order to subtract, we need a common denominator, and we have that. So it's 2/4, which is equivalent to 1/2. So it's x to the power of 1/2. Beautiful. Here, now when I take 3 divided by 1, that is 3. So part of my final answer will be the number 3. Let's change colors to keep things straight. Part of my final answer will be 3. But I am dividing the same bases. So I subtract the exponents. And I specifically take the top exponent minus the bottom exponent. Of course, we need to have a common denominator when we add or subtract, because subtracting is really like adding the opposite. So 6 is also my common denominator, or least common multiple of 2 and 3. So this is the same as 9/6, and this is the same as 2/3. But again, I'm subtracting or adding a negative. Oops. 1/3 is the same as 2/6. That gives me 7/6. That is my power on the base of x. So it's x to the 7/6. Now, again, I have this 3 out in front from 3 divided by 1. Boom, shakalaka. Here, if we have the same power, we can simplify that. So if you have, it's really going this way. If you have the same power, which is, this would be like a to the 1/n, and this is times b to the 1/n, you can really multiply what's in the radical together. So that applies to this situation. I'm multiplying some values together that are being taken to the same power or root. So this is the same as the 5th root of whatever 27 times 9 is, which is the same as the 5th root of 243. Which is approximately 3. 3 to the 5th power is 243. Who knew? Same deal here. This is really the 3rd root of whatever 54 times 4 is, which is 216. Now that one I actually thought, I was kind of starting to do some math, and I'm like, well, something times itself 3 times, it's got to be 216. And it is. It's 6. How's that for excitement? Here, I can split that 4th root amongst the numerator and the denominator. And that's what I'm going to do here. See if I can simplify that a little bit more. So we get 13 to the 4th root divided by 81 to the 4th root, or the 4th root of 81. Now the funny thing about the 4th root of 81 is that's 3. 3 times itself 4 times is 81. Now that 13, that's going to be a decimal, and we can leave it that way. The 4th root of 13 divided by 3. All right, so what goes on here? Number 10. I'm going to divide that, because that says 15 divided by 3, which is 3. What do we do when we have the same bases? What do we do with the powers when the same bases are being divided? That's going on here in blue, and it's going on here in green. That's just like this concept. We subtract the exponents. See that right here? Dividing the same bases, we subtract the exponents. Dividing the same bases, we subtract the exponents. So let's get to work. Oop, there we go. So in blue, and this is from the yellow part. In blue, it's really the same as x, take the top exponent or power and subtract the bottom power from it. So that's equal to x to the negative 4/2, which is equivalent to x to the negative 2. We'll hang on to that for a second. In green, I didn't highlight enough last time, so I'm going to make up for it now. I'm going to really make up for it. I'm going to go this way too. Ooh. In green, same idea. We're dividing the same bases. So I subtract the top power. I take the top power minus the bottom power. So 4/3 minus 2/3. I have a common denominator. I forgot to mention that there. I had a common denominator, and I have to have a common denominator when I add or subtract fractions. I've got it down here as well. So that's going to be equal to y to the 2/3. So this y to the 2/3 can go on top of the fraction bar. But recall, when you have a negative exponent, it makes it a traitor. It goes to the other side of the fraction bar. So instead of it being on top, it's actually on the bottom. Bada bing, bada boom.